Welcome to the introduction on our Vibrotactile Codec, our contribution to the Haptics Symposium 2020. To get a realistic vibrotactile sensation, many interaction points have to be rendered on the human skin. While for one point data rate is low, even a small number of points may lead to high data rates. In this example, with only 50 points, we already have 2.24 megabit per second. So we need to reduce the data rate, but that essentially means that we distort the signals. By exploiting human perceptual limitations, we can shape the distortions to be imperceivable, and that is the goal of our Vibrotactile Codec. So how does it work in detail? First, a block unit splits the input signal into blocks of block lengths chosen between 32 and 512 samples. Then each block is decomposed into frequency bands using a discrete wavelet transform with CDF97 wavelets. In parallel, we transform the block into frequency domain and apply the psychohaptic model to it. This model computes masking thresholds from the signal spectrum. These masking thresholds model the fact that strong stimuli will mask weaker stimuli at nearby frequencies. The masking thresholds are added together with the absolute threshold of perception to the so-called global masking threshold. After that, we compute the ratio of signal energy to threshold energy in each wavelet band. These ratios are used in the quantizer, where the wavelet coefficients are quantized adaptively depending on how perceivable the signal in each wavelet band is. In general, where the signal is less perceivable, we quantize with fewer bits, and the other way round. After quantizing, we have a so-called spite coder, which further removes redundancy. Together with side information, we finally encode the bit stream. Examining SNR and PSNR performance, we can see that the codec performs as expected. Signal quality decreases as we compress more heavily. To evaluate perceptual quality, the ST-sim metric has been proposed. Applying it to our signals, we can see that perceptual quality remains high even for high level of compression. The subjective quality of the compressed signals is currently examined in a human user-based study.